Hi, this is Lester Martin with Hortonworks University, and we're going to continue on with our Hadoop Essentials course. This next module is titled Ecosystem Components and Integration. What we're going to focus on here is definitely give you a breakdown of the various components and frameworks that make up a Hadoop distribution, very specifically Hortonworks Data Platform, HDP. And we'll look at them in the construct of these 5 pillars you see listed here that we'll definitely cover in the next few slides. We'll also talk about when it's time to take your distribution and deploy it in the data center, what Hadoop itself, what kind of machines and servers that Hadoop runs on, and the various stereotypes in those cases, and then how Hadoop itself fits into existing data systems, data applications that you have to build out what we refer to as the modern data architecture. So first up, let's run through the Hadoop components themselves. So when you hear about Hadoop, you sometimes hear Hadoop or the Hadoop ecosystem. Obviously, Hadoop core, the HDFS, Yarn, the compute and the storage capabilities that we'll talk about just a little bit more coming ahead are the basics, the base and the foundation for the ecosystem. But we wrap around that technologies such as the ones I'll show you here. And I'll focus on the logos and just give you a little bit of information about them. Scoop and Flume are ingestion technologies. Pig and Hive are definitely some of the most mature transformation, analytic engines. We have some additional frameworks that have come up in the last few years to help those tools go faster and better and we'll have higher performance TES and ORC. We surely have workflow type tools or data pipeline type tools, Uzi and Falcon that sits above and on top of that. And then there's definitely management services, some of which are management like Zookeeper, the nice gentleman on the bottom down there. That helps with the various components themselves, so kind of a framework. And then other operations perspective, such as Abari, where people are administering, configuring, managing the life cycle of a running Hadoop cluster. Security components such as Knox, and then NoSQL systems like Accumulo and HBase, and search engines like Solar. And definitely we want to account for real-time streaming analytics too, because that's extremely important. Where data comes in, and we want to take action almost immediately as the information streams in, and then push that information down into Hadoop proper. And then, of course, no good conversation about Hadoop would be complete without discussing Spark, which itself is on the cornerstone of actually possibly displacing a number of these other technologies, or at least giving you other options for deployment. And that's kind of a common theme you'll see in Hadoop anyway. There will be times and use cases and requirements that can be satisfied by various components. So something to consider and to think about. At Hortonworks for HDP, we like to look at Hadoop in these 5 architectural pillars. Down at the bottom, what we call data management itself. This is and this includes the storage elements of Hadoop, and as well as the compute elements. So HDFS and Yarn are components we'll just talk about in the very next slide, I believe. We like to definitely see this notion of data access tools. This is a data framework, and these are your kind of workhorse systems. And you might hear the phrase various workloads. Those are what we talk about: real-time search, interactive, batch, NoSQL streaming, etc. So those are the kinds of things that fit into that data access. And then we kind of bookend management and data access with things that make sense, kind of cross-cutting concerns, governance, integration. How do we get data in and out of the system, the Hadoop cluster itself? How do we govern those activities where the data is sourced from, etc. And then on the other side, of course, we've got to definitely bookend this security. Security has to be a solid, bolt-on for all things data. That's just paramount. It's part of being an enterprise class. And on that theme of enterprise class is a slew of operational frameworks, and we'll just walk through those in the next slide here. So we Right out of the gate, I mentioned that data management. That's what I would call our Hadoop core. That's the HDFS, the Hadoop Distributed File System. That's what it sounds like. It's an interesting concept. It's a file system like you think of on your Macintosh, your Windows machine, or not, or even your servers. But it's comprised of many servers at runtime that come together to create this, in some ways, logical file system that has built-in not just speed and performance and scalability, but built-in reliability, considering that it's built upon many servers to get the job done. So we'll talk through in a further module the architecture of HDFS, how all those things come together, because it is critically important to understand as you're developing your Hadoop skill set and going down this Hadoop journey. Just as important, so if HDFS takes care of storage, then we have a concept called Yarn, a framework called Yarn, that's taking care of compute. And storage and compute are the basic foundations, again, the Hadoop core, to consider. And you see what Yarn stands for. It's kind of somewhat catchy, I guess. Yet another resource negotiator. And this is the framework that frameworks leverage when they need to run in this cluster. So those various workloads that we kind of mentioned, and you'll see on the very next slide, integrate with Yarn and say, hey, I need this amount of resources. Help me find them. Help me allocate resources across the cluster and let me go run in that space. We'll mention a few of the operational frameworks on the slide as well. I touched on Embari. That Embari is kind of that Embari is that tool for administrators, operators of your Hadoop cluster. Monitor, deploy, configure, start, stop. That's the kind of that operational tool set, and it can integrate with other operational tool sets. Just as important is Zookeeper. I mentioned that one. That was the gentleman with the big shovel, and you can imagine if he works at the zoo and has a shovel, what he's going to do. But that's what his focus is. He's looking at it's more of a runtime framework for frameworks to leverage, to share information, to make themselves more resilient. And there are a few others listed here. CloudBreak is a concept or a piece of software that allows us to deploy clusters in the cloud and various different cloud providers. Oozie is our workflow engine, the basic cornerstone workflow engine that you see in Hadoop that lets you stitch together activities from a variety of these components. Probably the most exciting pillar to most people is the data access frameworks, and to be honest, we have many different data access frameworks there. This is the ones I mentioned: Hive and Pig. Those are, again, the workhorses. Well-oiled machines have been out there. Almost probably 9 out of 10 clusters are leveraging Pig, Hive and Pig in their environment. And Hive is much like a SQL. It appears like a SQL engine. It's sitting on top of this big, large file system and lets you build queries, lets you define tables, etc. And while Pig is much more of a, we would refer to as a data flow, a data pipelining style language that lets you do operation to an operation to an operation, and a somewhat more familiar kind of scripting flow to it. HCatalog is a component of Hive for the metastore information. HBase, Accumulo, those are our NoSQL systems that we have as part of HTTP. Phoenix is a way to bring JDBC operations to HBase. HBase is it's a NoSQL, not only SQL system, so it does not itself support your standard ANSI style SQL. Phoenix is a framework that allows you to kind of bridge that gap. And the last of the ones we're listing there are Storm, our real-time streaming processing engine, Solar search engine, and then Spark, as I mentioned. Actually, many of the things I just said, Spark actually has either in Spark Core or extensions to Spark, such as Spark SQL or Spark Streaming, an opportunity to give you other options to some of the other frameworks you have there. And that's a good thing. A governance, integration framework. So, governance first, things that help us know what data is existing in the system, help us catalog it, help us remember it, help us understand where it came from, where it's going to. So a lot of that is in Atlas. Falcon is a workflow tool that thinks about governance, has some pre-baked workflows that fit into that governance cycle. And then the rest of those technologies there would fall into the integration side of this kind of larger pillar. And again, that's getting data into and possibly out of Hadoop. And the ones you think of probably are Flume and Scoop. Flume is pretty good for moving files from all over the place into Hadoop, and Scoop is our ingest and egest, or import and export tool for relational systems. So it can talk and think about SQL and pull that information and bring it into the file system itself. Of course, the far bookend I mentioned, we got to have security. Security is critical. Now, what you see here is actually listen to a few of the frameworks we just talked about, such as HDFS, Yarn, Hive, etc. And what that's really trying to make the point is, since these are a bunch of independent Apache Software Foundation projects, they all have, of course, accounted for security. Now, being independent projects or applications or components, they've actually accounted for it many times, especially in the authorization element, slightly different than each other, as well as auditing. So they all have their own, we have a consistent core authentication. We can say yes via Kerberos that yes, Lester is Lester. But when we get to the authorizations page, each one of these components do their own thing. And so this brings in a product that you see listed down at the bottom, an open source component called Ranger, and that gives us an opportunity to centralize, commonize how we express and build these policies across all these services, and also gives us a consistent and compiled and consolidated audit log, which I actually think it's really, in many cases, the strongest point of value, at least I see out there. Other technologies that we'll discuss in the security module are Knox. It's just an additional perimeter concept beyond what we would refer to as an edge node, and I'll show you a slide or two from now when we talk about node types, what I mean by an edge node. And if you put those 5 pillars together and run them across the bottom here and say this is part of HTTP, you'll actually see this slide that you might remember from the previous module. And again, really just want to point out that HTTP, our Hortonworks distribution of Hadoop, is 100% open source. And we really try to visualize and understand and talk about components and the roadmap to those components in those pillars that you see below. So kind of the second half of this module is kind of that notion of in the data center. What do we do when we take a Hadoop? How do we deploy it itself? And then how does Hadoop as a cluster fit into the rest of your applications? So a couple things to think about is we definitely have this notion of stereotypes when we deploy Hadoop. And the primary 2 stereotypes are this one you see here on the left, this concept of a master node. And these were the brains, I guess you could say, of the file system, of the resource negotiator, of apps such as Hive. These are our centralized services that will orchestrate activities. They really don't run the processing themselves, the heavy lifting, but they do a lot of orchestration. And those live in these master nodes. And while I show 3 here, and I only show a handful of services, there is a number that will satisfy your level of reliability and comfort and those type things. That's probably going to be bigger than 3 in most clusters that get past that introductory size, but it probably isn't going to be much bigger than, say, 10 or so. It all depends. Sit down, definitely work with your consultant, work with yourselves, find that right mix. It may be bigger than 10 for you. It may be a lot less than 10. But it is a finite number of servers that will run our master processes on that control everything that happens in the cluster. I also show, just because I mentioned it, this notion of things like an edge server or even our perimeter tool called Knox. We kind of generically call those utility nodes. And again, these will be a small number of servers that you use for getting data in or out or giving folks a landing zone, etc. What's unique about Hadoop is that we actually have the scale out stereotype, the environment that we might start out with a handful of these, maybe 6 or 7 of these, 10 of these, 15 of these, But as we get going, this is the environment that will scale out to get to the nth degree. And we'll actually make sure we put some operational controls where we treat these boxes kind of a little more laissez-faire than maybe the master nodes. So the master nodes are very important. Well, all these services have built-in high availability, but they are kind of dependent. Once if the HDFS component fails and the high availability component takes over, we're at a point now. We're at a single point of failure opportunity. So we definitely need to shore these up quickly. But we're definitely going to be making sure that you don't have to wake up in the middle of the night by the fact that you might have tens or hundreds or thousands of machines down here in the worker class, and they will break. And so you're going to build processes that allow you to sleep through the night, solve a problem either tomorrow or maybe on a regular weekly mode. And this next slide is just really want to reinforce what I mean by this. We're gonna again have a finite number of masters, but we're going to keep scaling out those workers until we get that right size and combination that makes sense for your environment. So once we get the cluster itself deployed, we want to take it, we're in the data center now, and then we're really thinking about now, how does this fit into my overall comprehensive, holistic solution? And something that we refer to at Hortonworks as the modern data architecture. And we see Hadoop, really being a +1 architecture fitting in this data systems space. You already have a lot of other repositories, data warehouses, possibly some MPPs, definitely some relational systems that house a variety of information. It's not the intention of Hadoop necessarily to displace this entire class of processes. Now, that does not mean that Hadoop won't come in at times and displace some amount of these services. In fact, that's a good thing. Will save you a lot of good money. But you're probably very deeply, intrinsically built in your environment, you're an enterprise, leveraging a lot of these existing data systems, especially above that line into the application space. Lots of BI tools, reporting engines, dashboards, all those systems that you have today. We want you to continue to use them. So we want Hadoop to to find that right mix for your organization, where Hadoop is sitting in this this data systems tier to fit in. Would definitely use your op tools, your dev tools, etc. And we still see that you have your existing your existing sources coming in, such as your ERPs and that kind of stuff. Your existing data that you probably already have represented in here, and ultimately up into your reporting tier and your analytics tier. But we see it all fitting together, and I guess you might hear other things like a data lake, a modern data architecture. That's very similar terms, and I guess I would like to say that there are some basic foundational attributes of something like this, and they are just simply collect everything, put everything you can in its rawest form into Hadoop. It's cost effective, gives you many opportunities to recast, revisit, re-schematize that data in many different ways. You can dive in anywhere, like we mentioned in the previous module. There's not a specific use case that everyone has to start with and go to the next one. And then realize we have a lot of access to this data, including those data frameworks I mentioned, those data access frameworks, as well as your additional existing data applications that sit outside of here. So you're really building a extremely highly scalable solution that lets you go get data insights at a really much reduced cost than your existing systems today. And then this last slide here just says, what might that look like with some real technologies, some real processes, etc. that you have. So that's, we mentioned some of those here, and really just kind of calling out down here in the at the data layer, the data itself, the sources of data probably are going to be your traditional systems that you're already ingesting, and then some of these new sources you probably have already started and dabbled, etc. And maybe possibly we've only sampled or have short durations of history that you would maintain your data systems. Now that you have Hadoop, let's stop sampling and let's store forever. Let's just get it all in there. It's a great solution for that. And I think that takes us to our knowledge checks for this section. So I'll just run you through a few questions and see if you can peg the answers. So first up, in those pillars we talked about, data management all the way through operations, I'm just going to list off a few components and just looking for where you would suggest they fall into. So Embari itself falls into the operations pillar. HBase is definitely, it's a NoSQL system, so that fits in nicely in that data access pillar. We have HDFS for sure. That's pure data management itself. That's that storage element of the whole core of the grid itself. Scoop was an ingest or egest system that lets data come from relational systems into Hadoop. So I put that in the the governance and integration pillar. And then Ranger was our consolidated tool for managing authorization rules and policies, and then ultimately the consolidated audit log. So that's our security pillar for sure. So true/false question: how about the number? Does the number of master nodes grow in proportion to the number of workers? So if I've got 10 masters and 100 workers, when I have 1,000 nodes workers, do I need to have 100 masters, or do you need to continue to grow at that scale? And absolutely not. There's going to be, obviously, there's an opportunity to continue to reevaluate and specify and make changes to your master nodes, but generally speaking, that's a static set of nodes once you've got the level of reliability and comfort that you need, and then you continue to just scale that worker out, tens, hundreds, thousands, and beyond of worker nodes. And then maybe when I was talking about that modern data architecture, think about data sources. If you could list out or think of some data sources that are probably new to most organizations, and I would say those are weblogs or weblogs at scale, maybe even email with the kind of unstructured nature of once you get into the message body itself. Sensor data is what's really driving so many organizations today. Social media, etc. And one more true/false question: is it Hadoop's goal to displace all existing data sources? It's definitely not the goal of Hadoop. Hadoop is a +1 architecture. And you know what? Even if we really, really could displace everything technologically, again, the likelihood of us Hadoop coming in and displacing everything that an enterprise has deployed and worked hard on the last 5, 10, 20 plus years is somewhat of a short-sighted and not really thought out solution. So a quick summary. Again, those 5 pillars that I mentioned and we just discussed through some questions. And the stereotypes as we deploy Hadoop, the most prevalent ones, the things that you'll be thinking a lot about are those masters and workers, the static list of masters, the ever-growing list of workers. And we reviewed, how Hadoop is going to fit in with everything else you have and how we're going to build out this modern data architecture. So that takes us to a demonstration where we'll focus on just kind of giving you an operational overview with Embari. We'll look at Embari, that administrative tool. While we won't do lots of administrative actions, I'd like you just to see the kinds of feature sets, etc., that Embari brings to bear and helps manage. Thank you.